Hello everyone, I'm Demidovich and today I'll explain the hard problem from Calculus 2. My problem is 2641 um, exercise from the Demidovich book. So in the exercise it asks what is the magnitude of the error if we put approximately. E is approximately equal to 2 plus 1 over 2 factorial plus 1 over 3 factorial and plus 1 over 4 factorial. So as we know, the exponential function e is represented by the infinite series, where the sum of the series of e is e over n factorial, where n is equal to 0 and goes to infinity. But in this exercise, we get only the first few steps of the infinite series. So we start by calculating this term of this series. And after calculating all these factorials and fractions, we got that this part of the series is approximately equal to 2.7084. And we call this approximate value as E approximate. Then we start calculating the remaining part. The R here is our remainder, represents the error we get when we cut the series after the fraction of 1 over 4 factorial. Mathematically, it's represented by R is equal to E minus E approximate. However, instead of calculating R exactly, we are interested in finding the upper bound for the magnitude of R. And okay, now let's calculate the bound of the magnitude of R. So the next term in this series is 1 over 5 factorial, which we didn't include in our approximate value fraction. Because the factorial fraction grows very quickly, the terms of the series decrease rapidly. Thus, 1 over 5 factorial gives us a way to bound the error. So we can express the magnitude of the remaining part of the series as less than sum of the 1 over n factorial when n is equal to 5 and goes to infinity. We're calculating this series gives us a very broad boundary, which we're not looking for. So we'll substitute it with a more simplified boundaries. In order to find a simplified bound, we say that R is less than 1 over 5 factorial, which is equal to 1 over 120, because 5 factorial is equal to 1 over 120. And then as we know, E is approximately equal to 2.718, which is less than 3. After knowing all these, we can calculate that E over 5 factorial is less than 3 over 120. And when we get the reduction of this fraction, we get 1 over 40. So as a result, we can conclude that the error of approximation R is less than E over 5 factorials, and also which is less than 1 over 40. Thank you for your attention.